Among programming languages, assembly language is the closest to the bottom layer. When programming, high-level languages such as C language are usually used to write programs and then convert them into assembly for execution. But nowadays, interpreted languages such as JavaScript and Python have become more popular programming languages. Software can be developed more easily and quickly. So, what is the difference between them? In simple terms, the higher the level, the more wasted the performance of the machine, but saves the time of program development. The lower the hierarchy, the opposite. Nowadays, in many cases, in order to not only ensure the efficiency of machine operation, but also reduce development cost as much as possible, we may need to take a hybrid approach. For example, C language and JavaScript language. First of all, the logic is complex, but the number of executions is small, and most of the complex interface logic is implemented by higher level languages. Then, the parts with the simple logic but a very high number of calculations are done by C programs, such as image compression and encoding tasks. In this video, let's learn that WebAssembly, which compiled from the C language code to run in the front end of the browser or in Node.js, and how does it interact with JavaScript. For example, when the J side calls the function of the C language, how are the parameters of the function passed? First, there are huge differences between JavaScript and C. For example, C language has pointer and structure variable types, but there are no similar concepts in JS. JS has concepts such as string variable type, object, etc. C language does not, but we can find a way to convert. String corresponds to an array of char characters, that is, character pointers. Object represents multiple key value pairs, which can be similar to struct. When JS is running, a memory area can be allocated for the C program. For JS, it is a buffer variable. This shared memory area can be read and written by both parties. The essence of reading and writing here is just the numbers. Let's look at two typical examples. The first is how the string in JS interacts with the C program. The memory here is assumed to be read from bottom to top. A similar variable in the C language is an array of char characters, which is actually a pointer. Then a char pointer points to the beginning of the array. Each unit is a character encoding and is 8 bits in size. A part is omitted here, finally ended with 0. Well, these concepts are for C language programs. The numbers in binary here are just examples. The JSI needs to be read according to the rules of the C language. For example, code like this. Convert the starting address pointer and the length of this array to typed array. That is, each array element is an unsigned integer, 8 bytes, and each number is the number of the character. Then we read the numbers one by one, and then use these functions to convert the numbers into string types. Finally, stitch them together. Then the reverse the same. Then, to be more complicated, if there is such a structure in C language, which contains multiple key value pairs, similar variable types are equivalent to object in JS. Similarly, the premise of wanting to read is to understand how the structure is stored in the memory where the C program runs. So I wrote this piece of code. Use the size of function to calculate the structure and the memory size of each child member variable. Then get each child member pointer, get their offset in the structure. Run and see this result. A is int, 4 bytes. B is char, 1 byte. C is double, 8 bytes. That's right. Then we look at the offset. This is how it is shown. Addresses are from bottom to top. They are in the order we declared them in the structure A, B, C. However, why does B occupy only 1 byte, but it needs to be offset by 4 bytes? I checked the information and found that each subnumber will be aligned according to the size of its own variable type. That is, here is start of A, so it starts as 0, is an int occupying 4 bytes. The second one, B, starts from 4, and the variable C, if not aligned, just start with 5. However, now it must be a multiple of its own size. Double is 8 bytes, so it is a multiple of 8 as the starting offset. So greater than 5 but a multiple of 8. The minimum is 8. So 3 useless bytes are to be filled after B. Makes variable C start at 8. Well, to understand the placement of the structure in memory, we can write this configuration information on the JH side for this. Of course, it is better that this configuration information can be automatically generated according to the previous rules. Forget it here. Next, for example, use buffer in Node.js to traverse all variable members, and then obtain the corresponding values from memory according to the type and the offset. The same is true in the front end of the web page. In fact, if you are willing to use C++ class or C++ struct, in fact, using the Inscription tool, you can directly use the enm bind or WebIDL binder. You can directly bind classes in JavaScript to classes in C++. Still, it is helpful to understand the reasons behind it. Alright, see you next time.